Hey everyone, welcome back. And in this session, we're going to be talking a little bit machine learning, a little AI ML, a little wavelength, and doing this at the edge. My name is Jeff Marushak. I'm a senior solutions architect on our DoD Air Force team. And my co-host, Adrian, you want to introduce yourself?
Hey everyone, my name is Adrian Salmiguel. I'm a principal partner enterprise architect here at AWS. And today we're joined by a good friend of ours, Robbie. Robbie, would you mind saying hi?
Absolutely. And first and foremost, thank you both for having me. It's great to be here.
Anytime.
Glad to have you.
And for everyone tuning in, my name's Robbie Belson. I'm a developer advocate here at AWS, and I'm part of our worldwide telecom business unit. So I spend most of my time focusing on our global community of telecom operators, really trying to help them embrace new opportunities around transforming their business, reimagining consumer experiences, and digitizing industries. And what that means for us today is I have a natural interest and affinity to all things AWS wavelength. It truly is the perfect convergence of network and cloud, abstracting away the complexities of mobile networks so you don't have to. And today we're going to talk about how we work backwards from customer requirements to try to figure out how do you do machine learning at the edge and what does this mean for the AWS cloud continuum as a whole?
So just to let you know, this segment's only 15 minutes long. Do you have that much time to go through all that? Is that something you can handle?
Challenge accepted. Let's do it.
Let's go. All right. So as we think about trends that impact the data, where the data is generated, who needs to consume it, AI/ML workflows have to be part of this. Explain to us how important these mobile applications are when working with wavelength, what you're so interested in, and getting that data closer to customers or sometimes closer to the machine learning model.
It's a great question. I often think about a great analogy. Denise was talking about it earlier in terms of traffic or rush hour traffic. So imagine the following. You're driving home from a long day at work. You're at exit 3. You just passed exit 1, and you got a traffic jam. And you're like, man, I should have just gotten off at exit 1. In many ways, that closer highway exit is AWS wavelength because you're bringing familiar AWS compute and storage topologically closer to the end user, but also where that data is being generated. And so what that means for you is if you're trying to develop a highly immersive machine learning application, you want to bring not just the data closer, but the compute that's serving that machine learning model. And so today, as Amr mentioned, to kick off this, I guess, theme of sessions, Wavelength supported today in 30 cities all across the globe. And so what we wanted to do is really figure out how we could deploy machine learning applications at the edge. But at the end of the day, what I love most about Wavelength, and I think what's important for those hearing about Wavelength for the first time, you must be thinking, man, building 5G networks, that's got to be tricky. That's got to be new service introduction. At the end of the day, it's just another subnet. And we'll see that as we walk through a quick demo later.
That sounds awesome. I mean, we're talking about wavelength. We're talking about bringing compute closer to people. I got to say, and I have to throw it in there, I'm at the edge of my seat. Sorry.
Oh, boy. Let's just keep going. Let's just keep going.
I got to throw it in there. I'm sorry. So, we're talking about geo-distribution and bringing compute over to where people need it, where the individual workload may reside. I've got to imagine that developers, builders, architects, all sorts of folks are faced with different challenges on how to actually do it. It's one thing to theorize, it's another thing to actually implement. You help walk us through that?
Absolutely. And I think this isn't unique to Wavelength, particularly for local zones as well. I found that customers are really trying to reinvent what does it mean to build a geo-distributed application. And in Denise's session, she was also talking about some of those patterns with online gaming. But let's talk about it from an infrastructure perspective. What are patterns we were seeing from customers? Because customers kept asking questions around, how do I make it easy? I understand that I can launch a wavelength zone instance from the AWS console. You go to the EC2 section of your console, you can see a wavelength zone instance right alongside that of the parent region. But if I'm building a geo-distributed application, say 10 wavelength zones all at once, how do I manage that? And so Amazon EKS, or our managed Kubernetes service, quickly became a pattern of choice. And I want to show you a quick example just in my on my laptop here of what that actually looks like.
Okay, yeah, that'd be awesome to see.
Very, very quickly, assume you have an EKS cluster here and you've launched worker nodes, not just in, say, US East 1, the region, but US East 1A, 1B, so two availability zones.
Yep, yeah.
But now you want the Boston wavelength zone through our partner Verizon.
Okay.
You want Chicago, you want Dallas, you want Miami. I'm pretty sure different permutations of those two cities are separated by over 1,700 miles.
Yeah, a little bit.
So that's different. That's a different type of geo-distribution we haven't seen before. But when I just run kubectl get nodes, So what are the nodes in my cluster?
Well, you said kubectl, isn't it? kubectl?
Potato, potato.
AMI.
But what you're seeing here, right? You wouldn't even know that it's a different availability zone. And that's by design, abstracting away the complexity of the network itself, but still providing you the information that you need. So when you show that the labels for each of the nodes, you can see that some of the nodes, you've got Boston, you've got Miami, and so it's just represented as yet another subnet. So I think that's a really key point, that we've made geo-distribution easy. But that's just the compute. Customers then wanted to understand how to use machine learning workflows. That's where SageMaker comes in. And for those less familiar with SageMaker, SageMaker is our fully managed machine learning service for developers like me and data scientists to really experiment, build, test, deploy, and fine-tune machine learning models. And well, there's many different types of models that customers could leverage. I don't know what your favorites might be, but AWS Marketplace, pre-trained models available in SageMaker today, or built-in algorithms, rather. I'm a big fan of SageMaker Jumpstart, particularly with the advent of generative AI. More models than ever. You got more than 500 to choose from. So I started thinking, man, there's got to be something there. So I reached out to a few of my friends and specialists in SageMaker, and we came up with a pretty nifty implementation.
Well, Robbie, I don't know about you, but I am not a data scientist. Adrian, are you a data scientist?
If it's possible to be the negative data scientist, I am that person.
So I like SageMaker Jumpstart for it allowing me to get into machine learning without having to be a data scientist.
I think so. And it's not just bringing a number of different models, but it's their solution templates that they have, or blueprints to help you build that 7-layer cake, having never been a baker. You'll see me reference these baking analogies, also having never been a baker myself. But let's jump back in. You look at this Jumpstart PY that I just created. A few lines of code here. What it's doing, and the key to SageMaker at the edge that we learned, is you can deploy models of choice that are managed by SageMaker via inference endpoints, or, key point, line 43 here, deploy locally. So if I wanted to deploy this locally, what's going to end up happening is SageMaker is going to pull down those pre-trained model artifacts and let you test it locally on your device.
Okay.
But why that's important is now you have the 3 layers in the 3-layer cake. You're going to get that base image, so the container that allows you to serve model inferencing requests. You're also going to get the model artifacts, the key logic, the pre-trained work, or the undifferentiated heavy lifting for ML that you didn't want to do. But you also get the compute orchestration in that it's running locally in Docker. Moving from Docker to Kubernetes, pretty easy. So now as the baker, I've got all the ingredients. And that's exactly what we learned, that if you have all these ingredients, you have everything you need to build machine learning applications at the edge.
That's great. So, Robbie, walk me through a scenario. So let's say we're at a concert venue. Maybe we're seeing some baby platypus rock band because they're so cute, something.
They are cuddly.
Yeah, so maybe we go to that concert venue and we want something to help the audience find their seats. Maybe some sort of photorealistic support or something like that, some text generation, et cetera, et cetera. What kind of, just kind of throwing that out there, what kind of services are available now to help AWS customers with something like that?
So like a voice bot agent or text-based support.
Yeah.
Well, one thing you could certainly do is Jumpstart offers GPT-2 as a supported model. And so you could deploy that model locally to SageMaker Jumpstart, extract those key model artifacts, and then deploy it to that same EKS cluster you just saw. And you don't have to choose in advance the right wavelength zones that fit your need. You can seamlessly auto-scale, again, taking advantage of the core value proposition of AWS and elasticity, not just in a discrete location, but in a geo-distributed fashion to say, I may not know where my customers are tomorrow, but when that happens, there'll be a wavelength zone ready for me, and I'll seamlessly scale to meet those customer demands, and that's what EKS lets you do.
That's pretty groovy, man. But I got to say, we're kind of starting to get into the weeds a little bit, and I'd like to pull this out for just a brief second. I enjoy the grokking, but we do have some folks out there that may not be very familiar with how customers are taking a look at this or how it directly applies to them. Can you help give some examples of that?
Well, I think look no further than our communication service provider CSP partners. The very blog that I hope is already being posted in the chat was started because I was collaborating with Verizon, and Verizon asked me, hey, how do we extend SageMaker to the edge to help with some of our managed solutions? So you'll find that with AWS Wavelength, a lot of the applications are out there are being managed by telecommunications providers to offer managed solutions so you don't have to manage the connectivity, the compute, or the software. Huge value proposition of Wavelength. But beyond CSP partners themselves, lots of really interesting verticals of customers taking advantage. Automotive is a huge one. You take the analogy of you don't want to download that multi-gigabyte game or update, you want to just stream to you. So remote rendering applied to gaming can also apply to over-the-air updates for vehicles. So you've got these new premium features for wayfinding or infotainment. And so the idea could be that instead of having it streamed, or rather fully downloaded before it's operationally viable, it's just streamed to you. It never has to live on the device itself because of how close it is to end users and geo-distributed.
So you're saying I don't have to keep the truck parked at the house to get that latest update for either the radio or the infotainment. Hey, here's new maps. Here's an update for cruise control. Ideally, that we're providing people ways to stream that and only get the bits that are relevant, so I don't have to stay there parked for an hour before I get going.
That's exactly what OEMs are starting to look at today.
Okay.
But even beyond automotive, you think about media and entertainment, and you think, oh, latency is that key value proposition for Wavelength. That's true. But there's so many other key currencies. We talked about data residency, that can be important. But I think reliability becomes increasingly important. We talked about a concert venue. How often you tried to do something on your phone, it just didn't work.
All the time.
The ability to have a more reliable source of ingest is so important. And so what we're finding is that working with our AWS Wavelength partners, you can deploy, say, models at the edge for image captioning or image classification, some sort of computer vision, to get that data back to the cloud in a more reliable fashion, not just because the compute was closer, but what we're starting to see is the convergence of low latency compute, be it wavelength local zones or services across the continuum, and network APIs offered by our communication service partners. So things like, I want to know which edge is the closest edge. I woke up in Boston, little road trip down to Miami.
Yeah.
Boston's still closest. You wouldn't have known that. I wouldn't have known that, but the APIs do. Also, you can start to think about things like quality of service. Can I elevate my quality of experience to upload those really important images or videos or assets so that they can get to the cloud reliably? And it's those types of use cases that I think are going to transform what AWS Wavelength looks like in the years to come.
Well, you talked about the key components of going to the cloud, that scalability, that elasticity. And you're talking about a concert venue, but think about all these music festivals that pop up and they take over a town for a weekend, and maybe you want to deploy that model in a local zone. You don't need to do it in all of US East 1, but it's in Miami. And so you can deploy that machine learning model in the Miami local zone and boom, directly closer to your customers.
And I think the flexibility you're seeing here
Yeah.
tells two important stories. One, the ability to have more choices than ever for where to deploy applications is critical for the next generation, not just of applications, but stringent user demands. What you wanted today will change in a year from now. You wanted a high definition stream today, you wanted a super high definition stream tomorrow. Text today, images tomorrow, videos the year after that. And I think the key point is that customers are continuing to want richer experiences, and through services like AWS Wavelength, we can deliver it. That's
Yeah.
point one.
Well, and 5G is making that even easier. Even it's opening the minds of the possibilities of what could be done to help that as well.
It also seems to be changing the network from a liability to a hard dependency.
Yeah.
I'll take it one step further.
Okay.
The network is becoming an asset to application builders. You're getting programmability in the APIs. You're getting programmability associated or flexibility for where you deploy. And most importantly, through the example that we've provided with SageMaker, I hope this demonstrates to all of you that that's just the start of how you might extend a native AWS service to some of these new infrastructure solutions. And we believe that this is a pattern you're going to start to see more and more to provide customers more choices than ever for how to extend the AWS cloud to the network edge.
Well, Robbie, those are fascinating examples. Thanks for everything, for painting this awesome picture. But for customers who want to learn more, maybe you've excited some people out there.
Certainly
Where
hope
would
so.
you suggest they go to learn more?
Well, definitely a number of options. We've got an AWS Wavelength workshop on workshops.aws. You can check out the Wavelength service page. You can reach out to a telco partner in a city near you. We can't wait to see what you build. We're super excited to see how 5G can help transform your business. But most importantly, just Just a pleasure to be here, and thanks so much for having me.
Yeah,
Thanks for joining and talking shop with us, Robbie. Always a pleasure to hang out with you. And folks, you'll definitely want to stay tuned. Up next, we got a pretty interesting series and group of sessions with a common theme. We're going to be talking shop about how you can bring AWS to your data centers and on premises for a consistent hybrid experience. We talk a lot about consistency, and we're talking explicitly on how we do that for you. You'll want to stay tuned. We'll be back after a short break.